So this is the second video in the Chapter 8 series where we're talking about mole conversions. And the first video we talked about going from atoms to moles, and from molecules to moles, and from moles to atoms, and from moles to molecules. In this video, we're going to actually switch gears a little bit. We're going to go to conversions of grams to moles. This is a lot more common. The reason is because we have a balance, and on that balance it measures things in grams. So this is a lot more useful for us. So mole conversions continues. It says here's another fact that you need to know. So our periodic table for a little while has just kind of been sitting there looking a little lonely, gave us a little bit of information, but here it's going to be a really big help. So for example, right here I'm going to replicate what our favorite organic compound-based element is, which is carbon. And 6 up here, you know, is the atomic number. And when we went over protons, neutrons, and electrons, we talked about the mass number, which is the protons plus the neutrons. And I said many, many times, I said, do not use the 12.01 for the mass number. I said that is the average atomic mass, which we're going to use later, and that later time is actually now. What's really convenient about all this stuff on the periodic table is that this number represents something really important. It says that 1 mole of carbon is equal to 12.01 grams of carbon. So whether you knew it or not, the periodic table is your biggest friend right now when you're trying to do conversions from grams to moles. All right, so let's go ahead and move on to an example question. So converting from grams to moles and vice versa, which is why I use that double-headed arrow. Please, please, please know that when you're just going from grams to moles, you are not using Avogadro's number, which is 6.022 times 10 to the 23. You don't use that here. You're going to just use the masses off your periodic table. For this class, we're going to round to 2 decimal places. If your teacher says to round to 1, go ahead and do that. Your numbers really shouldn't change all that much. So let's go ahead and look at this first question. As with any conversion question, we're going to rewrite the given number at the beginning. So 23.4 grams of Fe, Fe again being iron, as that's one we forget sometimes. So we're going to go ahead and take this unit at the beginning and go ahead and put it down here in the denominator in order to cancel it out. We're going to leave a space in front of the gram, so we're going to talk about where that gram number comes from. And we're going to go from grams to moles. So where we finish is moles, and we're going to put moles here. So if I look at the periodic table, I'm going to see that the periodic table tells me that 1 mole of Fe is equal to 85 grams of Fe. So that means that the number that's associated with grams here is going to end up here. So I have 55.85, and that 1 mole is going to go right here. So now what I'm going to do is divide 23.4 by 55.85. I'm going to do that real quick and then tell you how you know if you're doing it right. So 55.85, and I get an answer with 3 significant figures based on that initial number, and I get 0.419 mole of Fe. So again, when we get to the end of a question, we want to ask ourselves, is our answer right? So if I know that 1 mole of Fe is equal to 55.85 grams of Fe, and I look at what I start with, which is 23.4, I know that I'm going to have less than 1 mole because 23.4 grams is less than 55.85. When I look at my answer, I get 0.4, which is about right considering that 55.85 and 23.4. 23.4 is probably a little less than half of 55.85. And it's really important when you're doing these problems, especially if you feel like you might get confused, to look at your answer at the end and see if your answer makes sense. All right, so we went from grams to moles. Let's go ahead and switch it up from moles to grams. So again, in this case, we're going to go ahead and write our 4.34 moles of sulfur. I'm going to make our parentheses and go ahead and put our mole of sulfur down here on the bottom, the denominator to cancel. So mole of sulfur, and I'm going to put grams of sulfur up here. When I look at the periodic table, it says 32.07 grams of sulfur is equal to 1 mole of sulfur. So I'm going to go ahead and put 1 in front of the mole and 32.07 grams in front of the gram unit. So here, I'm actually going to multiply. So I'm going to have 4.34 multiplied by 32.07. I'm going to end up again with an answer that's supposed to be in 3 significant figures based on the 4.34. So I'm going to end up with 139, and that's going to be grams of sulfur. Again, don't forget the units. Let's assess whether the answer is right. So I have more than 1 mole of sulfur in my question because it says I have 4.34 moles. And it looks like you have about 4 times as many grams, which makes sense because you have 32.07 grams in 1 mole. It's really important, like I said, if you're worried about dividing or multiplying, that you check your answer at the end. So this seems all fine and good. And when we were talking about going from atoms and molecules to moles, it didn't matter what element it was. And it didn't matter whether it was a compound or an atom. In this case, it is going to matter whether it's a compound or an element because water cannot be found on the periodic table. However, water, H2O, has elements that make it up, and those elements can be found on the periodic table. So if we want to figure out how many grams are in 1 mole of water, I have to add up all of the masses of the individual elements. So for hydrogen, rounding to 2 decimal places, I have 1.01 grams per mole. And for oxygen, I have 16.00. These 2 numbers are coming from the periodic table, and I'm going to multiply them by the number that there are in the formula. So since there are 2 hydrogens, I'm going to multiply this number by 2, and because there is an implied 1 here, I'm going to multiply this 16 by 1. So when I do the math out, I'm going to get 2.02 for hydrogen, and I'm going to get 16.00 for oxygen. When I add the 2 of those together, I get 18.02 grams per mole. So now, whereas I could look at the periodic table to just get the element mass, I can add them together to get a compound mass. So 1 mole of H2O is going to be equal to 18.02 grams of H2O. Okay? So we're going to use that to our advantage in the next couple of problems that we're going to solve. These are also gram to mole problems, but they are gram to mole problems that involve calculating the molar mass. And the molar mass is what we just did for water. So let's go ahead and look at this problem we have going on. We're going to go from grams to moles. In order to do that, I need to figure out how many grams of NaCl are in 1 mole to start with. So 1 mole of NaCl is equal to some number of grams of NaCl. So now I'm going to figure that out. So Na, sodium, has a mass of 22.99. And there is 1 of them, which is going to be the same number. And Cl is 35.45, and that's multiplied by 1 as well. So in the end, I'm going to get 22.99 plus 35.45, so 22.99 plus 35.45, and I'm going to end up with 58.44, and this is going to be grams per mole, which means I can write 58.44 in my conversion factor. So what we're going to do here is say, okay, 87.45 grams of NaCl. Okay, so again, we're going to start exactly the same way as we started every other question. But now I'm going to take my grams of NaCl, put them in the denominator, okay, and then I'm going to put my moles in the numerator. I'm going to use my conversion factor, so I'm going to have my 1 mole here, and I'm going to put my gram amount, so here's the grams, 58.44, 58.44 here, and we're going to divide. Just a little word to the wise, okay? If I have 87.45 grams, that's more than 1 mole. So my answer should be greater than 1. So 87.45 divided by 58.44 is going to give me an answer. This time we're going to actually have 4 significant figures based on the first number. And I'm going to get 1.496 moles of NaCl. Note that these questions really aren't any more difficult than the ones we just did, except for the fact that we have to solve for the molar mass using this method right here. Okay? So let's go ahead and look at a question that really isn't any more difficult, but the molar mass looks slightly more daunting. So let's talk about calcium nitrate, which is what I have written up here. Just a friendly reminder, Ca is calcium, and NO3 is the nitrate ion that's combining with calcium here. Just a friendly reminder in case you're practicing your naming. So let's look at this for a second. So I know that I have calcium. I know that I have calcium. I know that I have nitrogen. And I know that I have oxygen in this compound. I know that I'm starting with moles and I'm going to grams. So I'm going to need to fill in these conversion statements that we keep talking about. So I'm going to need to figure out how many grams are in this. And we're going to work our way through it. So for Ca, the mass is 40.08. For nitrogen, it's 14.01. And again, for oxygen, it's 16.00. Now let's talk about what all these subscripts mean. So for us, calcium has a subscript of 1. Okay, that 2 on the outside does not affect the calcium. So we're going to go ahead and write a 1. That 2, however, affects both the nitrogen and the oxygen. So at this point, I now have 2 nitrogens and I have 6 oxygens. So now I have to go through and calculate the mass for each of the individual elements. The first one's pretty easy. So 40.08. I have to sneak these in the corner here. This is pretty easy math too, so I'm going to have 28.02. And then 16 times 6 is equal to 96. So now I'm going to add all of these numbers together. Let's see if we can get that box to go away. Or not. It's okay. So 40.08 plus 28.02 plus 96, and I'm going to end up with 164. Make sure that's clear. 164.10. This is grams per mole. So I can actually go ahead and plug this into our conversion factor, and we can go about solving our problem. So this problem, like I said, isn't any more difficult. It just involves you going through the steps to find the molar mass. So 7.87, again, one of our favorite numbers we've used in these videos. So 7.87 moles of CaNO3 2. I'm going to use my parentheses. Again, we're going to start with moles. Moles are going to come to the bottom. Moles, CaNO3 2. And on top, we're going to go to grams of CaNO3 Why? Because the problem told us that. And so now we're going to use our conversion factor once again. We have a 1 mole next to the CaNO3 and we have 164.10 grams of CaNO3. So here I have a number of moles and I have grams, and I'm going to multiply those together. And my final answer, because of the 7.87, is going to have 3 significant figures. So 7.87 times 164.10. So I end up with 1290 grams of CaNO3. Okay. For this question, it's important to notice a couple of things. One, that I have a really large number of grams, which makes sense because I actually have close to 8 moles, and each mole is 164 grams, so it should be a fairly high number. If you've been confused by the fact that I've been rattling off the significant figure numbers, and you're like, well, wait, there's this 1 here. The 1 does not actually pertain to the significant figures because it's an exact number. It is exactly 1 mole. So therefore, it has an infinite number of significant figures and will always have technically the most of them. And since I always round to the smallest number of significant figures when I'm multiplying and dividing, the 1 doesn't really play into this. A lot of the times, if you're in doubt, it's really good to look at the initial problem, so in this case, the 7.87, to help you figure out the number of significant figures that you have in the question. So that brings this one to a close, converting from grams to moles using not only elements but also compounds. Hope this was helpful, and I hope you join us for our next video.